Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, it is my pleasure today to introduce Brendan Dolan Gavitt, who is visiting us this summer from Georgia Tech, where he works with Vinky Lee. And then Wei Dongquei and myself have been extremely pleased to mentor him in what I hope you'll agree, is a nice piece of systems hacking in support of catching evil behavior on phones in the wild. Thank you.
Thanks. All right, yeah. So thank you for the excellent introduction. So yes, we're going to be talking about monitoring untrusted modern applications with collective record and replay. So the setting for this is essentially this sort of new emergence of a new kind of model for distributing and using applications, where you have sort of an app store model. And so Windows Phone 7, iPhone, Android all have this sort of centralized marketplace where you can go and download applications, and they're assumed to come from sort of known trusted providers. And even now, some of the desktops are starting to get this too. OS X Line released with an app store that has many of these same features. And so one of the interesting points about these is they come as sort of complete packages. And so in general, if you have two people running the same application, you can assume that it's going to have the same sort of code and data associated with it between two different people, which presents an opportunity for us, as you'll see. So, of course,
why is that the case for the existing desktop applications?
Because if I've got Office, 2010, and you've got Office 2010 64-bit, there's just a lot more, variance between different people.
But you could also have different versions of the software.
Right, but
For example,
it tends to be.
my app have it and you don't.
Mm-hmm. It's true. So it's not completely uniform, but it's much more uniform than it is on the desktop space right now. So of course, with modern apps, you get modern malware. So for example, on iPhone, there was this case of it turned out that Pandora was sending off people's private data to their advertising networks. Also, there's been sort of an upsurge in Android-based malware that can do things like recording conversations, the same sort of private data leakage, and things like that. So all of this is certainly something that we'd like to try and take care of. So we want to protect people from this kind of mobile or modern malware. And the current sort of state of the art is this kind of gated model, where you have a bunch of developers, and they submit their applications to one central point, and then that central point makes a decision as whether or not you're going to allow it into the marketplace. Now, of course, there are a few problems with this. One is that this sort of review process is currently very manual. You actually have someone sit down and you click through the application and try and figure out if it's good or bad. And so, of course, doing this costs a lot of money. Another issue is that, of course, even if you are very, very careful in how you review these applications, eventually you're going to let something through that turns out not to be legitimate and turns out to be malicious. You get an angry pig instead of an angry bird. So because this sort of idea that trying to focus strictly on prevention is probably eventually going to fail and allow malware into the marketplace, we want some way of being able to monitor these actual applications in the wild. And there are other reasons aside from malicious code that you might want to monitor these applications in the wild. For example, you might want to see if they're crashing too often, or you might want to be able to detect that it enables some behavior that's not necessarily malicious, but that the platform provider doesn't really want you to be able to do, like turning on a wireless access point on the phone. So our options right now are sort of divided into static analysis, which is useful in general, but is kind of limited in the malicious case, where the developer can apply sort of arbitrary obfuscations that can make it difficult for static analysis to get any sort of foothold. There's also dynamic analysis. And there you can try and do online monitoring, where you do all of your security checks as the application runs. But of course, these can be fairly resource-constrained devices, And so the overhead of that can limit the sort of analysis that you can do at runtime. So you could also instead record what's going on with these applications at runtime and then essentially do offline analysis later on. And so this is actually being done right now with platforms like Windows Phone. They're recording certain amounts of information at runtime, for example, crash dumps, and internal users at Microsoft who are dogfooding the OS actually are collecting information on battery life and things like that. So this is very useful information, but of course you have to sort of know in advance what you're looking for. And again, it limits what you can actually look at later on. So it would be nice to be able to record everything, but of course this is somewhat expensive. So the idea behind recording everything is an interesting one, though, and so we should take a look at it a little more closely. So one of the traditional approaches for doing this is essentially called record and replay. And this is where, when you run a program, you take all of the sort of non-deterministic input to the program, anything that's going to make it behave differently from run to run. So this could be, for example, the date and time. It could be user input, the state of the random number generator, and things like that. And then the idea is that if you re-execute that application later on and feed it those same non-deterministic inputs that you recorded earlier, it should behave in the exact same way. But unfortunately, this is actually still a bit too expensive. So there was a paper at ACSAC a couple years ago, I think, called Paranoid Android, where they essentially did this and recorded a few applications like the web browser, the email client, and so on. And they found that this imposed essentially a 30% overhead on battery usage. So it ran out 30% faster. Yeah.
At what level were they doing the logging?
System call interface.
Sorry?
System call interface.
Okay.
So this is the kind of thing that I'm already not exactly thrilled with the fact that my phone runs out of battery by the end of the day or after 2 days. I really don't want it to run out any faster. So this is kind of unattractive for users to be running all the time. So we'd really like to be able to reduce overhead here. So in an ideal world, or at least an ideal sort of panopticon world, we would be able to get full execution traces of every execution of every app all the time. Because then we could, for any analysis that we could think of, we could sort of go back to these execution traces, reproduce them exactly, and record any information we wanted, do any sort of heavyweight analysis, and so on. So what we really want to do is find some way to get the benefits of this kind of recording, but without this extra overhead. So, yes?
So the previous works like Clone Cloud, perhaps Paranoid Android, I guess their sort of goal is to do analysis in the emulator in the virtual machine or in the cloud, so that before that thing happens on your machine, on your device, the cloud can help you make a decision so that the consumer, whatever, the people who are providing this the trace, execution trace, can be also protected.
Mm-hmm.
But it looks like in your case, I'm providing trace to your machine for your analysis, but I won't get protected, right? Because you do offline analysis later on.
Right. So
if my data is lost, then
right. So it can be seen as kind of complementary, right? Because while being able to do this sort of proactively in the cloud is great, we feel that unless you actually can see in the wild behaviors actual users interacting with these applications, you're not going to be able to expose the range of behaviors that are seen in the wild either. And there are a few examples later on, but you can consider something like something where it's a puzzle game, and once the user solves the puzzle, it unlocks this malicious functionality and starts sending their data away. In that case, an automated analysis up in the cloud might not be able to solve that puzzle. Might be sort of too many paths in the program to explore, but a user just playing around on their phone at the bus stop is going to expose that malicious functionality. And if we can record the sequence of inputs that led to there, then we can actually have a chance at seeing that malicious behavior, detecting it, and pulling the app.
Another perspective, let me add on a little bit, is here is a crowdsourcing, have a current AV model. If there are 1 million users running this, there's 10 guys are compromised first. Then the signal sent back to the server, and the feedback loop is fast enough. Then the 1 million minus 10 will be protected. We're not trying to protect the 1 million people right at the point, because we think that's not sustainable given all the overhead, given all the performance limitation. But by leveraging this crowd, we can still protect the 900,000 people instead of 1 million people, which is 50% overhead, or 900,000 people with very low overhead. I think that's a way to look at the model compared with the existing one.
Another thing I want to add is if it's live, and so it will be, so at that time the user might not have the right bandwidth. So network bandwidth will be very important, right? Also like how the user bandwidth will charge user money at that time if you go in the live. So we need to consider those. So this, I'm thinking, will be another perspective as well. And also like if we do the analysis later on, like that bad app can be revoked from a license perspective, and if the app get revoked, then it will not damage your phone anymore.
Okay, I think he was first.
So you mentioned, like, as opposed to manual review, which is very expensive, the record and playback functionality would help you catch this kind of behavior once you have a sufficient self-host population, or let us say even if it's out in the wild. My concern is that you have to be able to identify what constitutes malicious behavior in a means that you can pick it up in an automated fashion very easily. This assumes you know all the ways that an app can behave maliciously, given that they're all written very differently.
So that's actually more of a benefit of record and replay, because it doesn't assume that you know the malicious behaviors beforehand. Rather, if you discover that some kind of behavior is malicious later, you can go back and look at your saved traces and re-examine them for evidence of this behavior, right? So maybe you didn't know that invoking this API with these arguments would jailbreak the phone, but now you discover, a month or so down the line that it does. You can go back and look for applications that have been using that API that way earlier. So, in some ways, we're sort of trying to separate out this idea of what constitutes malicious behavior and what data we can give you that will allow you to detect that malicious behavior.
As a follow-up to that, I understand that the self-hosting mechanism is great for this and gives you a huge amount of trace information. Collecting trace information, as she said, on each user's box and sending such a huge amount of data up may be very expensive when you're on a costed network. So are you limiting this to only free network, like Wi-Fi networks or something like that?
So our approach here is actually
storing data as well.
Yeah. So our approach here actually is going to be to try and really minimize both the amount of data and the runtime overhead that's going to be recorded on any individual phone. So we're hoping that won't be an issue. And also, of course, we're going to do this, the usual trick of taking the logs and only uploading them when you're on a Wi-Fi network, say, so that you don't, eat into their 3G bandwidth. Okay, you had a question.
So at some point you're going to talk about what happens if the malware writer is aware of your framework and tries, for example, to create polymorphic applications, whereby essentially try to get it such that every individual user essentially runs a different application, right? And therefore it makes it more difficult to merge this stuff. Because it seems like in the scenario that Wei-Dong was describing, whereby you try to do this thing where maybe 10 people get exploited, and then we sort of get an idea of what's going on and help everyone else out. Well, if you can't do that merge in the first place to say, okay, these are sort of similar traces, it seems like the...
Yeah, so, for the current Windows Phone and other kind of models, it's not as much of an issue because things like managed code and Silverlight don't actually allow you to generate any code at runtime. So the code that you start with is the code that you get, and you can't do self-modification or things like that. Going forward,
Yeah, not reflection.m. You can generate. You can do code injection.
Sure. Yeah, Mango we have dynamic methods.
But you can use self-modifying as a way to detect this is a malicious behavior. For any modern app environment, I can imagine they wouldn't allow you to do a self-modifying code.
They are going to allow it.
No, self-modifying code? No, they are going to allow native code, but not allow...
They are going to allow code injection.
Right. But going back to the point...
What do you mean code injection?
You're going to allow code reflection emit, right? That's my
Yeah, the
understanding.
flashing image is
Yeah.
allowed, which you can then originally copy with.
But you can just write your own interpreter, right? I mean, you can write your own.
Right,
interpreter.
and people have. So I think one of the things that we'll get to is the level at which we record things. We're not recording full instruction traces, we're going to be recording things like touch events. So the kind of polymorphism you have to pull off to make that happen will be something like, we're going to give you a different UI to every user. And that's an excellent question about how people will react, and we'll see how that happens. But I think it'll be harder for them to react than it is, say, in the traditional malware case, where it's trivial to get polymorphic shellcode that does exactly the same thing, but through some transformation.
Yeah, good question.
But how do you collate these events for the same applications?
Well, we know it's from the same application because it'll be signed by the same key, which says this is application foo.
So, are you saying that can be signed by many different?
No, I understood your question, correct me if I'm wrong, to say you have the same application, but for different users. Like it looks at the IMEI of the phone or something, and it has like a different path that it takes, dependent on that. So we always know it's David's evil application.
For that,
We
you
can
don't
already
need
treat that
polymorphism,
as,
right?
we can already treat
You
that
don't
as
need
an
code
input.
emission for that.
Sorry?
Right.
You don't need code emission for that.
That is correct.
Yeah, we
Yeah.
just treat that as an input, right?
Yeah.
The code that takes
Yeah.
something as
Yeah.
an input, then decide take different behavior.
Sure, but the issue is that depending on how the explosion of the
Yeah.
branches
Right.
they're taking, that can make the analysis very
Oh,
difficult.
yes,
That's
yes,
right.
Yeah.
yes.
Okay, so getting on to sort of how we might want to think about reducing the overhead of this, one approach might be to sort of say that we're going to throw away this idea of having exact reproduction of, instruction by instruction reproduction of a given execution trace. So, given this sort of space of possible executions that are seen in the wild on clients, we can think about a sort of neighborhood around that, which are the sort of ones that we want to be able to reproduce on the server. And we certainly want that to include the set of things that are seen in the wild, but it can also include some things that weren't actually seen in the wild but are still feasible that could have happened. And then, of course, this is all within the total space of possible executions for an application, which is a much larger space and much harder to explore. So our sort of key idea here is, again, we're going to take advantage of the fact that many clients are all going to be running the same applications in the same way, and we're going to try and distribute the logging work among them. So this idea is conceptually similar to this cooperative bug isolation, where essentially if you have lots of people running the same thing and you think that the same things are going to be happening to them, you can record events with some probability on each one. And then an expectation over a large number of users, you're going to see all the events that happened. And so then by each person uploading these small pieces, we're going to try and recombine them later on the server. Yeah.
So the motivating example they use is like the malware that triggers this malicious behavior at very rare events, only when you solve this puzzle. But if you do this probabilistic logging, then maybe you're likely to miss those rare events. So how are you going to take care of
Right.
that?
So the point of describing the kind of puzzle scenario wasn't that a puzzle is something that's so difficult that it's rarely going to be solved by any person. More that a puzzle is something that's going to be difficult for an automated system to go through and solve. So if you have,
You're gonna miss certain rare events, right?
yeah,
So
if you have something that only
is that the
affects
kind of
like
trade-off
two
that
people, yeah.
you're doing?
Exactly, that's a trade-off. of
It is a
how
trade-off.
much overhead you want to put on each device,
So-
how long you want to wait, how many devices you're running,
Think-
and how often that event happens. Put together, we'll decide.
So think back to the ideal world we talked about. If privacy wasn't an issue and network bandwidth was an issue, you record the entire execution of every phone, everywhere, and all apps. So now the question is, you can trade off and back off. If you say, I want 0.001% battery overhead, no 3G network usage, we can give you that. That's kind of what we're looking for. But the trade-off is you might miss some things that are rare.
Or wait
Also,
longer.
if you have a lot of people,
Yes.
Yes.
then make that up.
Yeah. So this is better for the angry birds of the world than for my random app I
Yes.
submitted yesterday.
Yes, yes.
Right. I mean, the other thing is that you could also think about doing different strategies for how you weight the probabilities. Right. You could say try and weight the probabilities so that events that you haven't seen before are going to be weighted more heavily than events that you have seen very frequently based on historical information from the server. So you might be able to push down these kinds of profiles for how you want to record. So just to give a quick example, so say you've got some sort of application and it gets some private data about the user and then gets where they are and what the current date and time are. And if they're in a particular place, say San Francisco, and it's Friday the 13th, then it's going to trigger this malicious behavior and send it out. So if we can record on, say, a bunch of different devices, that we get Alice's private data, Bob's private data, we get GPS data that someone's in San Francisco, and we record the date and time from 2 different phones on 2 different days, then now we can recombine these and try and get replays of different scenarios, like Alice, San Francisco, Friday the 6th, Bob, San Francisco, Friday the 6th, or maybe Alice, San Francisco, Friday the 13th, and that's when we're actually going to be able to see this malicious behavior in action. So that's sort of the high-level goal. And again, as we were just mentioning, the idea here is to be able to control these kinds of trade-offs, where if you have some sort of target performance goal that you want to hit, we can now tune this logging, and it's going to take you longer to be able to see the full range of behaviors, or at least the full range of behaviors you're interested in, but at least you have that sort of knob that you can turn.
So, going back to earlier question, so because of the way you're going to replay, none of these users actually were affected by the right here, because none of them actually saw all the 3 conditions being satisfied.
Right, potentially. So in fact, this could enable this kind of proactive detection. It's sort of random chance, but it's because that we have this sort of bubble around actual in the wild executions that we're trying to reproduce.
And I think it's important to note every execution in Kano is absolutely feasible, right? This isn't like stack analysis where it's a false positive. If we see an evil execution, we can go to the app writer and say, your app is evil, here's the execution, here's why it's evil.
It's just that in the logs, none of them may have actually seen the reason.
That's
right.
correct.
Yes.
Okay. And so, we've been talking a lot about sort of different applications that you can now build on top of it. Yeah.
So what if this malicious behavior depends on some concurrency issues? For example, I have a data race, atomicity violation, whatever, and I assume you are not loading that. So
right. At the moment, that's a fairly tough problem that we haven't tackled. Essentially, it's the kind of thing that traditional record and replay has spent lots of time on. But it's not something that we've necessarily considered in the sort of collective case.
On the other hand, concurrency just explores this makes the space, whole execution space bigger. And with just more executions, you still have a chance to reproduce the concurrency issue. In some sense.
Yeah.
And I guess, again, there's sort of a trade-off here. Depending on how delicate the concurrency issue is, the less likely it is, as a malware author, that you're going to be able to successfully execute it on actual people's phones, right? So there is a trade-off there, too. So going back to sort of applications, we can, again, try and do this kind of detection and reconstruction of malicious behavior. We can try and do things like taint flow analysis to detect these kinds of privacy leaks that got Pandora in trouble. We could even start trying to do things like, trying to expand that space of executions that we see on the server side by actually mutating the inputs to things that no user saw. Trying to, of course, keep them constrained to things that might realistically have come from the environment. So you're not going to have, February 31st, but you could have. You might try, other different dates and so on, and try and expand this neighborhood around in the wild executions and discover these kinds of hidden behaviors. So you could also, be a little bit smarter than just pure fuzzing about that. You could try and actually solve for inputs that are going to get you into new parts of the program using something like symbolic execution. And this would be sort of mixed symbolic concrete because, of course, we're starting from an initial set of inputs that came from real users. And the hope is that, if you have executions that are close to what users are seeing in the wild, they're going to be more relevant than ones that are just sort of pulled out of the ether. Yeah?
I think I'm confused about the puzzle thing. Suppose that to solve a puzzle you have to
It's a very simple 15 puzzle. You just swipe right, left,
puzzle
whatever. I don't know. Some puzzle. It's like 15 moves where you move things. If you just collect a little piece from me and a little piece from him, I'm gonna swipe right, and you're gonna swipe left, but no amount of putting that together will solve the puzzle.
And so that's still something that we have to work on and address and figure out, how we can put these pieces back together in something that's coherent. And maybe in some cases we won't be able to.
Jay will be able to help us. He knows how to solve puzzle. Which is hard Jay.
Exactly. As we described, we haven't done this yet. We have thought about, and I know G2 has thought about, and Sharad has thought about, sort of adaptively changing the amount of instrumentation you do depending on the application. So if it's a puzzle application and we know we need this much contiguous touch events in order to get through it, we can actually adaptively push that down. Right? And then we would see that because we'd see, oh, we're in this place in the state space of the puzzle. We're never getting deeper than this.
And that would adaptively feedback and know that you have to collect longer sequences.
Right. In principle, we haven't done that yet.
Yeah.
That's the kind of thing.
Yeah.
Also, it's following on this puzzle thing. So the puzzle that the client has at that moment wouldn't be the same, would not be the same as the puzzle that you pull down when you do replay, right? So so currently you're ignoring all these server inputs.
Not the case. So input from the network would be also considered an input potentially, right? So the idea here is, so I think it's similar to his question that you may have coherency issues in that one user's input on this part of the program doesn't correspond to another user's input on this other part of the program. But things like, pulling down the puzzle from the server would be recorded with some probability.
Would that be a lot of information if you record a lot of things from the servers?
Again,
Given
potentially.
that a lot of mobile applications, they are, cloud-based.
Yep. Again, potentially, but the hope is that it's going to be less than recording literally everything, and that you can still get enough without having too much of a performance impact if you have a lot of users that are interacting with these, cloud-based applications. So, okay, so good example with that 15 puzzle. I guess this is. I know. Have you seen this before?
I have a plan.
You just walk by it.
Right, so you might have a 15 puzzle, which is a bit of a misnomer here because this looks actually a bit more like a 9 puzzle to me. But if you solve it, maybe now it's going to go and turn your phone into an access point, and that's going to violate all sorts of agreements with cell phone providers, and we don't really want that app to be able to do that. So this is the kind of thing that we're hoping to be able to reconstruct. So, okay, this sort of model where we want to probabilistically record and replay has led us to some sort of design principles. One is that recording really needs to be as inexpensive as possible in terms of the time it takes to do the logging, the amount of space that the logs take up, and the amount of extra battery that you're using up by turning on this logging. On the other hand, the replay side can be not quite arbitrarily expensive, but it can be much more expensive than recording. You're going to be recording on a dinky little phone and replaying potentially on a huge data center. So if there are trade-offs to be made where, we have to sacrifice and make replaying a little bit more expensive, but it's going to make our recording a lot smaller, then you should definitely take that trade-off. And finally, this goes to sort of what level of abstraction the events you are going to record are, is you need the ability to take events recorded on one device and events recorded on another device and be able to recombine them in a meaningful way. So doing this at too low a level, for example, would make that very difficult. If you have, say, mmap write to this device region at this time on one device versus another device, that's going to be very hard to interpret and reconstruct in a meaningful way.
There's also stuff like, let's say, physical form factor for display, things like that. Maybe that some phone has a display region where you touch it, but then another phone physically does not have that there.
Yeah, or for example, even in this picture, one of these phones has a keyboard, one does not. So that kind of input is something that you want to consider when doing your record and replay.
So you only replay for the devices who are compatible?
Or you can either do that, or you can try and move your recording to a level where those differences are abstracted away, right? You don't actually write a Silverlight application, one for the Samsung Focus, one for your HTC, one for your other manufacturer. The idea of these APIs is that they try and abstract away that, and that's the point of having OSs and APIs, right? So essentially gets to the question of where do we want to instrument, right? So we're looking specifically at Windows Phone here, and the software stack is actually pretty deep. So starting down at the bottom, we have the actual physical hardware, and then the Phone OS runs on top of that, and that's essentially Windows CE. Not essentially, it actually is. And then on top of that, you have your native libraries. These are the classic Win32 libraries that you're familiar with, but versions that are made for CE and run on ARM. A level above that now, and still sort of keeping the focus on sort of managed applications, we've got the runtime libraries for .NET and Silverlight and XNA, which are split into two pieces. They've got a managed side, which is what applications actually talk to, but then for performance reasons, and because they need access to the OS, large portions of them are implemented in native code. So you have this sort of split personality for each one of them. And then finally, way up at the top, you've got the actual third-party applications, which are the ones that we're trying to monitor. So there are trade-offs sort of at each level. As I mentioned, if you start down at the hardware and try to do recording there, you could imagine something like taking the approach that's been taken in the security world, where you do record and replay by throwing a VM at it and doing all your recording at the layer of the VM. You just record all inputs and outputs to the CPU and your virtualized devices, and then you can replay at that level. The problem, of course, is that this is going to end up being fairly device-specific and very hard to compare events that happen between different phones. Going up a bit, between the OS and the native libraries, this is sort of what the Paranoid Android case was, where they did their recording at the system call level. We wanted to sort of avoid that because while it is a nice sort of small and well-defined interface with sort of clear separation of state between kernel and user mode, it's not guaranteed to be stable. The one in Windows NT can change between releases, so can the one in Windows CE, and so on. And the way this is gotten around is that you have these user-level libraries that everyone is supposed to be using that define the stable Win32 API. So you could also imagine trying to instrument between the managed code layer and the native code layer. This again is kind of problematic because again it's undocumented, it's not exposed to developers, not guaranteed to be stable, and you also get some issues because here you're really mixing managed code objects, native code objects, and it can be kind of unclear how you should reconstruct these objects when you're doing replay. So now let's talk about sort of two more viable possibilities. So one that sort of seems really intuitively promising is sort of moving to the highest semantic level possible, right? Just below the application, where now the application's interactions with the .NET runtime and .NET runtime libraries are going to be recorded and replayed. And this, seemed really cool, so we actually went ahead and took CCI metadata, which is a very nice project that allows you to essentially disassemble, make modifications to, and rewrite .NET assemblies. And we instrumented the .NET standard library to do record and replay. Things did not quite go as we planned. The biggest problem that we encountered was that objects that are passed between the standard library and the application end up being sort of shared state between the two layers. And you really want a much more clear separation between the two. Because now, if you have one of these objects that's passed back into the application, you now also have to start recording not just the one object you pass back, but also potentially other objects that it references. So you have something that's sort of intuitively simple, like a little touch event at XY, right? You might think that this is sort of all you need to capture the semantics of that particular event. But when it actually reaches the application, events in .NET tell the receiver about who the sender was. So now the sender is the phone application frame. And the phone application frame might have references to other UI objects, the buttons, text boxes, and so on that exist inside it. And so the application, by following references from the object that was given back to it, may end up accessing a fair bit of the application's state. Another issue is that these touch events may not be pure managed code. They may also have large native portions that are attached to them that you would also potentially have to reproduce. Yeah.
So I'm just a little bit confused about why you have to log that entire graph. I mean, you're saying you have to log the entire, because it seems to me in a system where, let's say, you are just going to instrument a whole execution run, so you're not doing this thing where you're looking at just a single execution run, a single program. It seems like all you would have to log is just the touch and the X and Y, and then that whole rest of the graph would be induced by the fact that you know what the program state is. And,
right. So when I'm talking about a touch at XY here, I'm not necessarily talking about the sort of the theoretical event, but the actual .NET object that is given to the application. And that .NET object, when it's given to the application, contains these references to other objects.
I see. So this is essentially, if I understand you correctly, this is essentially a serialization problem, basically.
Yes.
That you are just trying to, record the event, but as it turns out, this event has some nasty object graph that ends up being difficult to flatten.
Right.
I see. Yeah.
And in fact, as you'll see, because we knew for touch it really should have been just XY, we should be able to induce it. That led us to the next design.
Okay. So this led us to move down. Yeah.
Instrumenting every store to that object or every reference to that object?
That was kind of the path that we were going down because, again, if you're replaying this from a log and the application may want some data that you get to from that object, you have to be able to provide that data. So this led us to try to move down a layer and essentially instrument at the second of the two stable APIs in the system, which is the Win32 layer.
This is specific to Windows.
Yes.
Phone setting.
This is specific to Windows Phone, though.
Other smartphone platforms you instrument at the system API.
Right. I mean, for example, on Linux, the system call API is stable. They may add later ones, but the APIs that you have at the syscall layer are in fact stable. So this is specific to Windows Phone. But in general, you can expect that if the platform provider cares at all about backwards compatibility, that there's going to be some stable API. Okay. So with this approach, the benefit is that, as compared to going up to managed code, the interface is a bit cleaner. It's a C API, and the amount of shared state between the two layers is much smaller. There is still some, and so you have to reproduce side effects and things like that in some cases. But it's in general much simpler. So when we're down at this level, I should mention some previous work, which is R2, which was a system by Guo et al. At OSDI 2008. Yes. And they're in MSR Asia, and it's very good work. But there's some sort of differences between the design of the two systems that reflect the fact that they have different goals and that we sort of want to move to this collective scenario. So R2 is sort of per application. You tell it the application and the interfaces that you want it to interpose on, and then it gives you a record and replay library for that. Whereas we want to really have this be sort of generic, we instrument the whole platform, and then as you add new applications on top of it, they're going to be recorded and replayed and supported. They also are very concerned with exact replay because they're trying to reproduce these kinds of concurrency-related issues, difficult bugs, whereas we're more concerned with monitoring and trying to get sort of this kind of approximate replay that we talked about. And finally, their recordings are all very instance-specific. They include details like the exact addresses given back by the memory allocator and try and make sure that those stay stable across, record and replay and so on. And whereas we're trying to really go for comparable recordings. So for our current progress, so this summer, we focused really on implementing sort of traditional record and replay for Windows Phone 7. This turned out to be a fair amount of engineering challenge because it's a new platform and so on. And of course, because we built one design and threw it away. So we haven't yet extended it to the collective case, but we're really hoping to be able to continue work on this project and actually move forward with this. So our next steps are to actually dog food this on real phones, maybe give them out to some people at MSR, support some more complex applications. I'll show you a demo of what one of the things that we have right now in a second, and extend this to the sort of collective scenario and, of course, run experiments to verify that all this actually does work. So getting into the details of the implementation, essentially the way we do it is you have an application and it makes some call into our native library. At this point, we've placed hooks in the native library, and so it's going to redirect into our library, at which point we can record whatever we need to, return control to that native library, and pass it back to the application so that we can record whatever information needs to be recorded. Once we get to replay, when the application calls into the native library, again it's going to redirect to our code, but now instead of invoking the native library again to get the results, we're going to read the results from the log file and return it back to the application. So as for how we actually do that, we make use of detours to do this actual hooking. And I say make use of, but in fact we had to port detours over to Windows CE. And there were some interesting changes that had to be made because CE is a different beast than Windows NT. So for example, in Windows NT, when you have a library that's shared across multiple applications, and someone goes and makes a change to that library, say by inserting a hook, Windows NT is kind enough to do copy on write and give you different copies of that library in different process address spaces. In Windows CE, when someone makes a write, that write is suddenly visible across all processes on the system. And this is because they don't really actually want you making changes to the user libraries. We actually had to modify the kernel to allow us to do that. So it's understandable that this doesn't work, but we needed it to work. So of course, now if we have this hook and it tries to call into our code and our code isn't in the other process, we're going to get a crash. So essentially we had to work around this by making sure that whenever some library we were going to hook was loaded into a process, that our recording library was also loaded into every process, and then it would decide dynamically, depending on what process it was, whether or not it was going to be recording and replaying that particular process. So stop briefly here for a demo, and that looks like me. Also looks like I have timed out, but ooh, that's exciting. Do I have caps lock on? Oh, that's the problem. Now, see, when you turn caps lock on, that happens. So, yep. It is not letting me in. All right. Yeah, I don't know. Let me try it with just starting from. I wonder if they realized I was leaving next week and just preemptively. All right. All right. So, okay. So, what we're going to do here is take a third-party application, in this case DrawFree, do some interactions with it, and record them, and then try and replay them later on. So I'm going to go in here, small application to allow you to record and replay. Right, yes. So record and replay, it turns out, also works on the settings application. And the last thing I did before this was set it to replay mode. So it replayed me setting it to replay mode. the system works a little too well. So anyway, it's now set to record mode. And so we're going to start up draw free. And so once it's loaded, we're going to take it, make a little drawing. You can all stand in awe at my artistic abilities.
10,000 smiley faces were drawn by Brenda.
Yeah. This is what you're getting for your money.
This is an arbitrary third-party application.
Right. We downloaded this from the marketplace last night, so.
There was no special filtering done.
Nothing up my sleeve.
You can get the same draw free from marketplace.
Yep. So now setting it back to replay. I'm going to go ahead and start the application up again. And if all goes according to plan, we should see it draw a smiley face. All right. Yes, we can also, we recently got recording and replaying of the HTTP layer working. So if Weidong can manage to log in better than I can.
Have you tried this on on the camera?
I haven't tried it on the camera, no. That's a very good question. We ought to be able to replay it at the same kind of level of abstraction because there's presumably a native library in there that's giving you access to the camera, but we haven't looked at it yet. Man, that raises a whole raft of privacy issues, doesn't it? All right, so starting up this, and so right now it's in neither mode. Hopefully I can actually go back. And so when we start this little toy app, what this did is it went and made an HTTP request out to a server and pulled back the current date and time.
It's the server in Georgia attack.
Yes, right. So our record and replay system is not yet so good that it can record events from the future. Future work. So now we can go and set it over to record mode. And you should notice that the time is different, right? So
it was the 48.
So now it's 14:49 and 27 seconds. So now we'll set this back to replay mode. And 14:49, 27 seconds. So, all right. So that's the demos for today. And can go back to, yes?
What happens if you switch between applications, Tombstone one and bring up another? Does that work?
So that doesn't work right now, essentially because when it tombstones one and comes back to the other, it detects task host launching again and assumes that it's a new application being recorded and replayed. So that's the kind of thing that we would have to essentially, build in some support for this kind of save and restore. But all right, okay. So to finish up, the sort of overall goal of this project is to really provide this kind of usefulness of full trace recording, but be able to minimize the overhead there. And so right now we've got an implementation of traditional record and replay for Windows Phone 7. And along the way, we learned some kind of interesting things that were somewhat unexpected. For example, this idea of doing recording up at the application level doesn't seem to work out very well with, at least with Windows Phone 7 and the .NET framework. And the other is that, depending on our design goals, it's going to really influence where we want to do our record and replay. And so that for this application, we ended up settling on the native interface. But we had to go through a few other designs before we got there. So that's it for me, and I'll take any more questions that we've got. Yeah?
So the problems you ran into by trying to do with the application level, because potentially there's these paths to arbitrary objects. And so you felt you needed to preserve all those just in case. did you look at any apps? I mean, do people tend to do that, or maybe it's the case that all you really needed was the touch XY and not anything else?
So this actually kind of gets to a question that was asked earlier, which is what do you do if the applications you're trying to monitor are aware that they might be monitored? So even if in the benign case, you can assume that maybe no one's really going to go and look at that deep part of the object graph, if it's not there, then a malicious application could use that as a way of detecting that it's being monitored and disable its malicious functionality. Yes, Helen.
So the possible another way of reducing the amount of recording that you could do is just to look at the program, use Sage to identify what are the input that's hard to reverse, then just focus on recording those, and let the smart fuzzing Sage to.
That's true, and that is an
do
interesting
the
approach, to sort of pre-process it with some sort of static analysis to really figure out what the bits you want to record are. So that's an interesting approach.
Yes, absolutely. Are there native functions that are deterministic, so you don't even have to? Another way to reduce the recording overhead is to say, oh well, these native libraries are deterministic, so
Yeah. So we actually ran into that when we were doing the HTTP recording and replaying. There's one function, internet crack URL, that takes in a URL and splits it up into its different portions. And while it was used by the application, and we had sort of tagged it as something that we might have to support, we ended up not having to. At the moment, the only way we have of doing that is manually, but it's possibly some automated process that might be able to identify these ones that are deterministic. Good question. Yep.
So I'm still a little bit confused about why you would have to record the entire object graph at all. I mean, it seems like essentially the object graph at any given point for, let's say, touch event, right? Like the object graph that event will touch is sort of induced by whatever the current program state is, right? So in other words, it seems like you've got your server over here, and correct me if I'm misunderstanding what you're trying to do. So you've got the server over here, and you're essentially collecting all these logs from the wild, and you're going to synthesize a couple of fake traces, right? And basically feed those fake traces to this real running version of the app on the server, right? So that server-side app boots up. It boots up with an object graph, right? Then you pass it a touch event, right? And whatever happens to be the state of that server application at that point, well, those will end up being the object graphs that it will touch.
Right.
So why do you have to record that in the
So
log?
if you have some extra information about, say, when a touch event is sent, who the sender is, then you could try to do something like go through at runtime and say, oh, okay, this object that's already in the application memory is the one that should be the logical sender. This doesn't mean that you need to have some way of identifying objects the same one over time, which isn't completely trivial. But yeah.
What you said is actually what we are doing. If you do at the native layer, all you need to do is send the touch event, the XY up, then the Silverlight and the application will construct the object graph. But if we sit on top of Silverlight, then we don't see the touch event XY anymore. What we see is a big object passing from Silverlight to the application. And the object has references. Without analyzing the application, we don't know what references the application would use. Then we have to give it everything.
I see. So so I don't know Silverlight that well. Is there any way to generate, let's say, like a fake touch event, whereby all you would specify is the X and the Y? Because it seems like if that exists, that would make sense.
So we could. There is a sort of monkey testing framework you could imagine using for this. However, touch is just one type of event, right? What we were trying to do with the original design is have a generic object logging layer for Silverlight. And so while you're exactly right in touch, we can actually sort of imagine sort of a better way of doing it. That would be a special case. And we found that, hey, we're going to have all these special cases. If we don't want to deal with all these special cases, it looks like it would be just easier to move down to a level where we have a really generic solution that wouldn't run into this problem.
We don't want to put our head into Silverlight.
Generic solutions but specific to Windows. That is the trade-off that you're playing.
Well, Silverlight would be specific to Windows as well, right?
Yes.
So,
have you considered covered channels? Or are they a non-issue?
That's not something that we have considered. So, yeah, it's a good question though. If you could have, I'm trying to think of what a covert channel in this space would look like. So now you're recording, and the covert channel would be something where maybe based on, actually I'm not seeing it. What sort of covert channel were you thinking of?
Go to one of 4 different URLs for the same site, depending on, on the 2 bits you want to ship now.
So this is talking about information leakage using by a covert channel.
Oh, okay.
Directly,
I see what you mean.
Yeah, that's one of the challenges to our applications. We would let them to worry about it.
Mm-hmm. Right.
You can just delay your request, and that delay itself can convey whatever information, like Morse code.
Right. So that sort of gets more on the side of detecting malicious behavior after the fact. And so, you know, if you want to think about it like this, we're sort of assuming that we have malicious behavior oracles that someone else is going to apply to the data we collect. Yeah.
So you mentioned the privacy concern.
Yeah.
Do you have some thoughts about that?
Yeah. So in some ways it's mitigated in that, you know, by recording only little bits from individual people, it's better than doing full trace recording. That may not be something that users actually buy. So there are a few things. You know, one is maybe make it something that they can opt into. But then, of course, this can hurt our coverage because we do need lots of people to opt in, right? The other is there has been some work on essentially trying to mask the kind of inputs in such a way that they still produce the same effect on the program, but they're not the original input, right? So there's some work on so perhaps the program execution is in itself the you know, private information potentially.
And a password, we don't save it. Like a credit card number, we don't save it. We can know this is a credit card number. Let's just ignore it.
So where that plays into our trade-offs, right? And say, here are some abstractions from the actual execution to protect users' privacy, and that just gives us a trade-off for something that we can actually take a longer time to catch.
So going back to the question about the camera, I said earlier, I was imagining that you would have something along the lines of giving the user the option of choosing which type of events they'd be willing to have recorded on their phone. So for example, I'm okay with you recording my click events, but not necessarily my camera recording. So maybe if you had a broad spectrum of users with different preferences, you could pick up for, say, more paranoid people.
Yeah, that is a good idea. I mean, there's always a danger in giving people lots of configuration options because they may decide that it's too much trouble to actually set them up. You know,
there's really no immediate benefit to that.
Yeah, it's not beneficial.
Right. It's more of it's sort of a social benefit, right? So on the other hand, there's what's the application for Android that you were mentioning? Lookout. That apparently, you know, again, it's security software that runs all the time, and it's had many users actually download and start using it. So people will, you know, some people do opt into it.
Lookout's an antivirus for your Android. So it scans all the apps running on your phone. It does the whole Find My Phone functionality. It sort of checks to see if that behavior is happening.
Send the information back.
And send the information back.
Right.
Yeah.
So, you know, people aren't totally uninterested in security.
Yeah.
Anyway.
Thank you.
Thank you.